All right, guys, and let's finish up question number 99. I know I left you hanging on the last video. So here we go. So looking at this, right, we had our regular hexagon, and I pulled out a triangle, and then I took one of those triangles and I cut it in half. We got the base. We need the height. There's two ways you can go about finding the height from right here. You can either use your Pythagorean theorem, a squared plus b squared equals c squared, where we have a, b, and then 6 has to be our c because that's our hypotenuse across from our 90-degree angle. So you'd have 3 squared plus b squared equals 6 squared. And then subtract 36, take away 9, b squared equals 27. So b equals the square root of 27. We can leave it right there. And if the area of this half of the triangle, our formula for area of a triangle, base times height, area equals 1/2 times base times height equals 1/2 times our base, our bottom would be 3, and our height at our 90-degree angle would be square root of 27. So then we can continue here. Actually, so this is my area for my half of this triangle, right? My next area for a whole one of these triangles, I could multiply this by 2 times all of this, 1/2 times 3 times square root of 27. And then those 2's cancel out. And then this triangle was one piece out of 6 over here. So now for this hexagon, I can take this answer, area equals 3 square root of 27 for one triangle. So multiply it by 6 for all of the triangles. That gives me 18. 6 times 3, 18 times the square root of 27. I'm going to break that up into 3 squared times 3. Then I can pull out my 3, and 18 times 3 square root of 3, right? My square and my square root would cancel each other out here. And 18 times 3 is that 54. And we have found our answer. Beautiful. I really like these geometry questions, I think, because we haven't done a lot of geometry in class this year. So this is a review, and I don't know, I just haven't seen these questions in a long time, and to me they're kind of fun. I hope that is the same for you. Number 100, if y cubed equals y squared equals z, then which of the following is equivalent to the expression 12x to the power of 5, z to the power of 2, y to the power of 16 over 6y to the power of 4, x. So I'm going to start by writing this bigger because that's pretty small font for me. And make sure when you're taking your test on CLT that you know how to zoom in and out on the test, because some of that gets, the print is tiny to me. I'm glad this is not on paper. I'd be in trouble. So we got 12. We got x to the power of 5. X, Y, Z. Look how they got X, Y, Z. I like keeping it in alphabetical order. So I'm going to move my Y in front of my Z. Y to the power of 16. And then z squared on the end over 6 y to the power of 4 and an x. So I rewrote it. My fraction is equivalent to that fraction, but I just, to me, it's easier for me to see how the things all line up together. So I'm going to press equals here, and 12 over 6, every fraction is that's right, division problem. So 12 divided by 6 is 2. So that's why all of those got the 2 there. And then x to the power of 5 divided by x to the power of an invisible 1. Well, I can take that 1, right, and move it to the top if I subtract it. And the same thing, I simplified that. Y to the power of 16 over y to the power of 4. Same thing, I can take that 4 exponent, because it's y and y, same base, and move the 4 up top if I subtract it. And I've eliminated my whole denominator now. So that gives me 2. X to the power of 5 minus 1 is 4. Y to the power of 16 minus 4 is 12. And z to the power of 2, that's the only thing that didn't change. Now I can erase this and look at my answer choices, and we're okay. We don't have a match. X to the power, we got a 5 and they got a 4. So it's not D, that doesn't match. And now we got to come in here and look at this first little piece of information. So anytime I see x to the power of 2, like we have x to the power of 4, I want to break that down into...
Good morning, teachers.
Oops, sorry.
Please be sure to stop by Mr. Guillaume's office to pick up your W-2s. Again, teachers, please be sure to stop by Mr. Guillaume's office to pick up your W-2s. Thank you.
So I'm going to rewrite this, and I'm going to take this x to the power of 4, and I'm going to write x to the power of 2 times, right? That's equivalent. I can do that. And my y to the power of 12, I want to pull out y to the power of 3. So y to the power of 3 and y to the power of 3, we're halfway there. Y to the power of 3, y to the power of 3. 3, 6, 9, 12. And z squared. Now, every time I have an x squared, that becomes a z. So that's a z, and these y to the power of 3s are also z's. Z. So that's 1, 2, 3, 4, 5, 6, and the 2 we already had, 7, 8. So it's 2z to the power of 8. And that one's done. And next we're moving on to number 101. And this is one of those logic and reasoning questions. Ooh. There we go. A chemist is studying the density of 4 different gases. If gas X and gas Y are each less dense than gas Z, and gas Y is more dense than gas W, which of the following must be true? Okay, that's a lot to follow. Gas X and gas Y are each less dense than Z. So Z is more dense, so it would sink, and gas X and Y each are less dense, so we know that. We also know that gas Y is more dense than W. Okay. So here's our 2 conditions. For me, I'd rather see it out like this than just read it. Um, Number one, must this be true, yes or no? Gas X is more dense than gas W. They didn't give us a comparison between X and W, so we don't know for sure. If gas X and Y are the same density, then sure, but they didn't tell us that. So that's a maybe yes, maybe no. It's not a must. So it's not one of our answer choices. Gas W is less dense than gas Z. W is less dense than Y, and Y is less dense than Z. So W is less dense than Z. That one does have to be true. And number three says gas X is less dense than gas Y. We don't know. They could be the same. One could be a little more, one could be a little less. We don't know. So the only one that must be true is 2. And moving right along to number 102, um, a sports equipment company needs to package baseballs into boxes for shipments to outlet stores. If each baseball has a radius of 1.5 inches and the baseballs are perfect spheres, then how many baseballs would be able to fit into a cubic box with one side measuring 24 inches? So they're going to pack them in a cubic box. And if one side is 24 inches on my cube for the length, it's also 24 for the width and 24 for the height. Assume that each layer of baseballs has the same number of balls as the layer beneath it. After the first layer is placed in the box, each successive layer of baseballs is placed directly on top of the layer below it. Okay, so if we can find out how many is on the layer at the bottom, we can see how many layers it'll fit going up. And right here, if we find our, let's see, 24, each baseball has a radius of 1.5 inches. So my baseball is a beautiful sphere, and it's got a radius from the middle to the edge of 1.5 inches, then all the way across, its diameter would be 3 inches. So how many baseballs can fit together in a row if they're 3 inches across and my box is 24 inches across? You just divide. 24 divided by 3 is 8. I can fit 8 baseballs across. So 8 rows of 8 on the bottom. And then for my height also, it'll be 8 sets of 64. 32, 48 plus 3, 51. There's our answer. For you see me going on these questions. I am drawing pictures for these questions. And even if they're giving me the picture, like up above here on number, oh no, they didn't give me the picture. Even if they had given me a picture of a hexagon, I would still draw my own triangle and my own half triangle on my scrap paper. You're allowed to use scrap paper on this test. Please do. Please don't sit there and think something like you're going to be embarrassed to show your work on the test. Don't do that to yourself. Show your work, show your thinking, prove your answers to yourself. It is worth your time to do that. Uh-oh, where's my mouse? How am I doing on time here? Oop, out of time.